Hi, everyone. Good morning. Welcome to the NVIDIA Tech Talks presented by Dell. I just wanted to let you guys know before we get started, we're doing something really exciting this year for us. We're actually live streaming these talks to Facebook. So you can check us out on the NVIDIA Facebook page if you miss any of the talks later on today. But just so you know, if you ask questions at the end, there's a camera in the room and we're live streaming. So I just wanted to make you guys aware. But I think we're going to go ahead and get started with our first presentation, which is Advanced Rendering Solutions. And we've got two of my colleagues here, Phil Miller, who's the Director of Software Product Management for our Professional Solutions Group at NVIDIA, and also my colleague, Michael Kaplan. So,
thanks, Victoria. Well, welcome, everybody. Thanks for coming in on a first day or early morning on a beautiful day. You're wasting a lot of gorgeous sunshine out there, so appreciate you being here. Today's talk, give you an idea of what we're going to be going over, is more high level than the rest of the talks during today. We're doing this because there's a lot of questions in people's minds about what is happening with NVIDIA and what was mental images. Earlier this spring, after 4 years of having mental images under our wing, we formally integrated it within the rest of NVIDIA. And so there's a lot of questions. And we're going to be talking about what that evolution is like and what it means to you. So overall, we're going to start with basically that beginning point, and then see how this impacts you, see about the new offerings that it's going to give you, some of the new concentrations that we're going to be having, and then have an overview of what we're producing and how this can impact your development life and what you can do with our technologies. Also, a roadmap of where these basic technologies are going, and then a glimpse of what we're going to be building next. So, starting out with the basics. So if you take a look at what NVIDIA was founded on, it was always based upon advanced graphics. This was the core of NVIDIA and always has been. And it's leading the industry from the beginning and is today. So it's not just a leader in GPU development, but also about GPU computing and also professional graphics. This show, SIGGRAPH, is perfectly made for what NVIDIA stands for. So beginning about 4 years ago, NVIDIA increased that commitment by acquiring Mental Images. Mental Images was the renowned company for component software technology that in a wide variety of applications, from the DCC applications and animation systems like Maya, Softimage, 3ds Max, as well as the CAD systems like CATIA, PTC, SolidWorks, and over into AutoCAD, Inventor, and Revit. So impacting quite a bit, but also servicing the needs of high-end studios, ILM, the Mill, numerous others that count on Mental Images technology for producing the special effects movies that you enjoy. So this relationship went very well for the first several years. And during that time, though, there was actually quite a bit other things going on within NVIDIA. So not only were we committed to the very high end with what Mental Images was doing, we were also working with enabling technologies that helped general development, both at this what we called application acceleration engines, low-level engines to help development, as well as with dedicated dev tech. Dev tech is NVIDIA's term for our highly trained personnel to go out and help companies get the most out of the GPU. They sit down on site often and code with people to do all the integration. This is extremely similar to what was happening at Mental Images for integrating their products directly into all of these products down here. The difference is that there were quite a bit more happening over on this side because the lifting was less. Here we are integrating entire solutions. Here we are integrating or accelerating just pieces of code. But in general, the disciplines were very similar. So we took a look at all the things that were happening between the two across the company and decided that there were greater synergies if we combined them. So beginning this spring, we basically took all of those groups and put them into one. So we're calling that now the Advanced Rendering Center. The center meaning the center of gravity for advanced graphics and for advanced rendering and professional graphics. What this means is we've got a lot of development now positioned or combined to service the general needs of the industry. So in the area of, like, for example, ray trace rendering, not only do we have the teams working on Middleware and iray, we also have NV Research as well as the OptiX team. For GPU computing, everything happening on rendering can leverage the expertise happening across NVIDIA. The same thing goes on down the line for many of the things that are core to producing advanced rendering in any situation. Now, the term, I should say the name mental images is being respectively retired as it is now basically NVIDIA. So the formal name of what you'll be seeing as far as who owns the technology or who copyrights are to and the like will be NVIDIA ARC GmbH. So in case you're seeing different names going around, this is what it means. So mental images name is simply transitioning over to the NVIDIA name, and with that being official now. So the composition of what NVIDIA ARC is we got about 120 people worldwide. The headquarters remains in Berlin, and with a lot of the management completely intact that we're managing before, and then combining with the management over at NVIDIA. Rendering development is under Steve Parker, who now also controls both OptiX as well as the high-performance computing DevTech. Core development is under Holger Kuntz, who controls his team comprises all of the basic core libraries that were happening at Mental Images, as well as the Monterey remoting technology you'll be seeing here demonstrated at SIGGRAPH, and the workstation DevTech, working closely with all the companies that were actually on the previous slide for CAD as well as DCC. Products and product marketing and bringing things to market is under myself. And business development is under Ludwig van Rijk. So basically, we have a cross-functional team that basically covers the world, both in where the development is and where the management is, and we're constantly communicating. So the combined organization then is actually fitted within the Professional Solutions Group within NVIDIA. This is actually a very good fit in the sense that PSG, as it's known, has been serving the needs of professional graphics from its beginning. That's what it was meant to do. So that's what it's always aimed at doing. It prides itself on solving the most difficult graphics challenges out there. Working with companies from anywhere from Disney to NASA to Autodesk on whatever they may need. And their focus, while be it hardware and driver based, is then a common focus with what we're doing in advanced rendering, being concentration on software tools, on studios, and on manufacturing. So very good alignment on who is working with which partner and who is looking after which customer. From a greater standpoint, one needs to remember that we're doing all of this because we come back to graphics being core to NVIDIA's foundation. And advanced rendering is core to NVIDIA's future. Raster rendering can only go so far. Games can only get so good. At a certain point, GPU computing needs to come in order to bring out what is possible with advanced rendering techniques. And this is what GPU computing is well suited for, and where a lot of our focus is on, because this is where the real change in how you work happens, is when the speed of things multiplies by 10, 20, 50-fold. To make this all work, to actually give us a chance in making sure that both our hardware architectures and our software tools are ready for the challenge, we need cutting-edge software development at hand to be pushing the limits, to be telling us where we need to be improving things. And we can't do this in a vacuum. We have to actually be producing the real code people use and be working with the products that people are producing. Otherwise, it's all theory. This then goes back and circles back to complete the circuit by influencing the GPU architectures, the languages, and the tools that everybody uses to create GPU software that leverages the GPU. So again, we're not trying to do this in isolation or as a one-off situation. We see it as a continuum, that the software finds out what the hardware needs, the hardware advances, the software keeps pushing. As the software is being evolved, we're finding out what needs to be done, and that all folds back into the tools that each one of you can use for your own development. So then if we take a look at what we actually have two sets of products and technologies for you to leverage coming from NVIDIA nowadays. We have basically the ARC products. These are the solutions. These are ready to use, ready to integrate, licensed, complete rendering solutions. These are things like Middleware and iray. This is a really good choice for companies that want to add a solution that they can count on. They might not have rendering expertise in-house. They just want to add something that works, something they can depend upon, and something that will advance for them. They don't have to worry about it. We're always going to be advancing these to be the best possible rendering solutions, taking advantage of the latest capabilities of the hardware. You get all that benefit for free as you're using these within your solutions. On the other end of the spectrum, we have the middleware. So middleware is free to use. And these are things like OptiX, Scenics, Complex, a lot of our libraries, all of our tools and languages. These keep evolving also with the GPU, always keeping up to date so you don't have to worry about it. These are a good choice for developers who want to create their own solutions, who want to differentiate, want to create something special, and have the expertise to do so. They will be maintaining it themselves, but the underlying engines or libraries will be evolving to keep them up to speed with all the evolutions of the GPU. So again, we are working to create underlying libraries that help everybody. And we're starting to use them ourselves within our commercial products now. So I've been talking to people quite a bit about the integration and how we're working with things. And one of the first things people ask is, why are you doing it? Aren't you a hardware company? Or aren't you out to replace renderers now? Are you in competition with me because I have a renderer? We don't look at it that way. NVIDIA views the situation as being, we want to accelerate all advanced rendering out there. And we see engines and libraries as a way to do this very easily. What we learn, we enable everybody to do it. And this then feeds back again into what is needed for GPU languages and architectures. On the commercial side, we keep things advanced. For example, when we came out with iray over 2 SIGGRAPHs ago, that was really pushing the limit of what could be done on the GPU at that time and really showed what was possible. We inspired many other people. So that is important to kind of like jumpstart the industry into realizing the potentials out there. At the same time, in doing a solution like iray, we know what's necessary for success, and we can then in turn help developers creating their own rendering solutions be successful, exploiting the GPU as well. So we see this as a grand circle. While we, of course, are going to be having a commercial offering, we do not see this as being the only commercial offering. We see it as a means for us to learn and to give everybody else out there what they need, both as end users, as companies, and as developers. So to sum it up, if you're developing solutions for advanced rendering, we want to help. We want to help you with what you're developing. We want to help you either with our libraries or with direct assistance. And we see you as a comrade in arms, so to speak, in conquering what is possible on the GPU and advancing what is possible in advanced rendering. So if you take a look at the rendering options from NVIDIA at this point, we have three primary platforms, or I should say two commercial platforms. We have the Middleware platform that is well known in the industry. This one is focusing on the needs of film production. Then we have what we call the iray integration platform, and it is focusing on the needs of interactive design. It will probably grow up to focus on more things as well, but at this point in time, it's really focusing on design. Then we have the OptiX ray tracing framework that is a general framework, not just intended for rendering. In fact, we estimate about a third of the developers adopting iray actually never create an image. They're doing things like magnetic reflection, ballistics, acoustics, things that are ray tracing tasks but do not actually render. The other two-thirds, though, benefit greatly from having a very rapid ray tracing platform upon which to create their applications. And we're really not taking a bet on any one of these. It's pretty evenly loaded across our overall organization as to how much influence or how much resources we have on each one, because each one is equally valuable. So the Middleware platform is one you've probably known the most. It's been around for many years. You see it in car, for example, car advertisements. You never know what is a car nowadays, or what is digital. You've, of course, seen Middleware used in many movies, coming from various studios over the decades. And as such, it is also, core to the primary DCC tools, Softimage, Maya, and 3ds Max. Also, if you want to get the very latest possibilities from Middleware, you really want to be using the standalone version. This one is available from Autodesk, and it is really ideal for studio pipelines. The one thing about the various tools is that you are on those tools have to expose the latest features in order for you to be able to use them. Well, there's sometimes a delay in that, sometimes months, sometimes years, in exposing what is possible within Middleware. If you're working with standalone, you can actually access the very latest that we've produced for the studios directly from your own pipeline. And so that's why the studios use standalone. Smaller studios tend to use it right out of the gate from the likes of Maya or Softimage. And Stefan, you can correct me anytime you want to. Stefan Romer, our product manager for Middleware, is there in the audience, and he'll also be here to take any questions you might have. Also, advancements coming this year. Stefan should really be talking about this. We're adding more production-ready lights and materials, including BSDFs, things that are ideal then for the needs of more film production, hair, skin, volumetric effects. Very fast and accurate motion blur that is fully ray traced, no longer rasterized. Fast and efficient and noiseless global illumination that works very well for massive scenes. Again, something that's very helpful for film production. It's something that we've been working with the studios to do well on. And then just general rendering speed improvements overall. And then what is somewhat new for Middleware is that we have recently been investigating how to add GPU acceleration to it. And you will be seeing evidence or examples of that even later this afternoon in the talk on GPU ray tracing, as well as at the end of each day at the booth. Bart Gowboy will be demonstrating the latest happening within Middleware and giving an example of where we're pushing things. So that demonstration right now is just concentrating on ambient occlusion. It is the exact Middleware 3.9 code and data pipeline, this time accelerated with OptiX. Now remember, OptiX isn't a renderer. OptiX is just a means to exploit the GPU. It does all the heavy lifting for you, so you don't have to. All the rendering code is still your renderer. So in this case, it's still the exact same algorithms coming from MentalRay. And if you were to do an XOR compare on these images, you would actually get black. They're exactly the same because it's the same rendering algorithm happening. The difference, though, is on a dual quad core, it's taking 3 minutes, a little over 3 minutes. And on a single GPU, it's taking 20 seconds. And that's about 18x. Now, that's for this first frame. We believe, actually we know, that we can get this far, far faster for sequential frames. So the speed up we're starting with is 18x, and we think this is going to get many, many times higher than that as we finalize this solution. What you're seeing at SIGGRAPH this year, in the tradition of SIGGRAPH, is a baby step towards what is coming next. So iray was debuted at SIGGRAPH 2 years ago. And then last SIGGRAPH, we actually started showing the first products working with it, bunk speed, and giving a sneak peek of 3ds Max. CATIA shipped later in the year. And by far, iray has become the most rapidly adopted renderer we've ever had. In fact, I'm not sure of another renderer that has gotten quicker adoption than iray has, not just by the people integrating it, but actually by the end users. The adoption rate coming by the various polling numbers on those products is quite remarkable as far as the number of people starting to use it. And the reasons are pretty evident. You get a push button, very easy to achieve photorealistic quality that is much, much faster than doing it with computer graphics tricks. So people who are designers that think that way, who think in realistic terms, this is a natural match for them, and they are gravitating towards iray quite rapidly. And we're getting a lot of interest for integrating it into various products. So for integrating iray, the solution we have, for lack of a better term, we call the iray integration platform. And it is really focusing right now on the needs of interactive design. I say it interactive because iray itself is an iterative renderer. So it progresses, which, while not giving you immediate satisfaction, it gives you all you need to know about composing your shot, getting your lighting right, are the shadows correct, are the materials correct, and so on. The iterative process, the creative process, is shortened much, much less because you're talking about seconds, not minutes or tens of minutes or hour between seeing a result. So iray is much faster to use. Wouldn't you say it's? I'm pointing here to Michael Kaplan, who's the product manager of iray. He'll be talking a little bit later. The overall integration platform itself is inherently interactive, so you don't have to do that as part of your application. It was built with the understanding that you want to interact with it. You want to model with it. You want to assign materials. You want to change the lighting. It also has built-in options for cluster rendering, something you don't have to figure out on your own, as well as multi-user capabilities, having people share the data or have the data produce multiple views at the same time. There are also APIs to actually control this thing remotely. By this thing, I mean your resulting application, as well as manipulate it from remote or from the internet. Another thing is that renderers built upon this platform that sit alongside iray can communicate with one another very, very easily. And they're very straightforward for us to add. And we're looking at doing that. But before we do that, let's switch over and actually show you some of the iray in action. Debuting here at the show will be Autodesk having now an interactive iray happening within the 3ds Max product. So Michael, why don't you take it away?
I've got a question there. My business partner now trying to follow it online, and you cannot see the slides. I wonder if it's possible to actually change it so that the slides can also follow along with the slides. They only have to focus on the
Oh, that's strange. So they're only we're only projecting me, poor people, and not the slides. So, okay. Well, thank you for that heads up. And now people are working on it. And now it's even more important to show the screen because we're going to do a demo.
That would be critical.
Right.
Can we get the monitor up on the screen?
Can we switch? No, just switch over.
There we go. And take your time. Okay. So at last year's SIGGRAPH, we previewed iray as fully integrated with 3ds Max as a production renderer, meaning that you would set up the scene in the viewport, push a button, and get a single image which would progressively come in, but you couldn't interact with the viewport or the scene while the image was being rendered. So this is what... Sorry? Okay. So this is what in 3ds Max is called production rendering. This year, Autodesk is announcing at the show a new version of Max, which will ship later this year. I believe in their subscriptions to their subscribers. And in this version, they have added an ActiveShade version of Max, Max using iray. So for those who are familiar with Max, they'll understand this. For those who are not familiar with Max, ActiveShade is essentially the interactive, high-quality rendering module for the Max product. It allows you to work in the viewport while also viewing the full final frame quality rendering in a separate window interactively. And so you can edit the scene and while you're looking at the final image results. This is really great for iray because iray, as Phil said, is a progressive high-quality renderer. And while you're looking at it, all the samples that are coming in are fully accurate. All of the effects that you see are fully accurate. And it's just a matter of time to resolve the noise and finish up sampling the frame. So what you see in the iray window, the ActiveShade window, is exactly the same as the image that you will eventually get out of the production rendering or animation process if you did it that way. And so let me, this is just showing this new version of Max. And of course, here we have the new Nitrous Max viewport. It's very nice. It does some nice realistic rendering using Direct 3D. What I'm going to do is bring up an ActiveShade window. And what it's doing now is an initial pre-processing of the scene to put it into the ActiveShade. It doesn't take very long. And now what you're seeing is the full global illuminated final frame rendering in real time as we watch. And this is being generated on one GPU. One Fermi-class GPU is doing all the work here in the window, and the other GPU is working in this window so that we have nice, smooth viewport interaction while we're also seeing the realistic results in this window. And you can see that in this window, the iray window, you're seeing all of the full global illumination effects, transparency, translucency, IOR, soft shadows, essentially infinite ray bounces, emissive materials. Everything that you can do in the production renderer is being done as you watch here. And now the nice thing about this is I can manipulate the viewport. I can manipulate the scene in real time, which I couldn't do last year. And so, for example, I could do something really wacky by bringing up the material editor, pick this material here, and I could just change the entire car body to physical glass. And you'll immediately see the result of that full glass simulation in this window. And now it's not completely finished. You'll see there's some spots and there's some areas where there's more sampling that needs to be done. But you immediately see what the final image is going to look like with all of its effects, not a series of tiles coming in, not a series of pre-processing steps, not a series of final gathers and other things being computed, but you see the image as it will be. If I let it run for another few minutes, this will essentially be the final frame. And you could save it off, or you could just go into the production renderer, push the button, and get exactly the same image. Now, this is a little bit different than some ActiveShade plugins that other people ship, in which what they're doing in the plugin is more of a preview or an approximation to the final frame rendering. They're very useful, and if everything that's in the preview is what you want, they're great. But there is a difference sometimes between what you see in the active shade view and what you see in final production rendering. In iray, that's not true. In iray, you're running exactly the same algorithm, and you're going to get exactly the same result. Now let me show you another scene. This is a fairly simple scene. Let me open one that has a little bit more of a design intent for architects. This is from a company called Delta Tracing in Italy. They are very heavy users of iray in their production process. They've built machines with 8 GPUs that let them do high-quality renderings at HD in 10 minutes that normally would have taken them hours to do before. So this scene has a lot of complex lighting, all the lights coming in through the windows. It's very subtle. There's also lights in the scene in this column, for example. And so this is a very difficult lighting situation. And so it'll come in a little bit slower, but again, only one GPU is working here. This is typically something that would have taken a very, very long time to figure out how to set this up and get the lighting right and set up all the materials. But you can immediately see exactly what the final frame is going to look like with all of the subtleties. So, and you can see the lights are coming from here. This is lighting the scene. So let's say, for example, I wanted to move or rescale this pot. I could simply select that. Let's say move it up a little bit. And then I could make it larger because we're having like a really big dinner tonight. So we need to have a really big pot. And you'll see that that is reflected instantly, or almost instantly, in the iray window. And, oh, I just scaled the walls. That's probably not something I really wanted to do. So anyway, this is a good example of what you can do interactively now in Max using iray, and this will be in a release coming out later this year from Autodesk.
Yeah, excellent. A couple things here. Even though it looks simple to do, changing things within a ray tracing environment means a rebuilding of what we call an acceleration structure. That's kind of expensive. Often this can take minutes, and it's something that the team has spent a lot of time on trying to minimize to work within an editing environment. So all the nuances of having to deal with changing data sets, not just in an animation, but in a live editing scenario, is something that we concentrate on so that you don't have to, because it's ugly. You don't really want to learn this. Also, Michael was mentioning in passing that we were running on one GPU and then keeping the other one around for the viewport. We're going to be doing this a lot, this SIGGRAPH. You'll be seeing it on the show floor. This is something that we're calling Project Maximus. And it's basically the pairing of a Quadro GPU for graphics along with a Tesla GPU for compute. This gives you a super fast and an affordable compute engine for all of your ray tracing needs while keeping your interactive graphics really, really smooth. Now, if you want to, you can, of course, double team it and double the speed of your rendering. But then the viewport gets a little clunky. So the idea is that keeping them separate gives you the best of both worlds. You'd never have a mouse freeze anymore. And this is something that we're working on both in the drivers and in the configurations to make this a lot easier for people. And so we're going to be demonstrating not on massive numbers of GPUs like you've seen in years past, but actually on using them smartly. Sanely, actually. One for rendering, one for graphics. Basically because the core GPU has now gotten fast enough to be very practical to use for your rendering needs. We don't need multiple GPUs anymore. They're already many times faster than quad or core CPUs.
Two GPUs, so you can watch it coming in twice as fast now.
Right. That's also a new feature, isn't it, within 3ds Max?
Yeah, that's a new feature.
Right. Giving you all the control over all the processors
right.
and things like that.
You can pick whatever collection of GPUs or cores you want to apply.
Okay. Did you want to... the other thing that was happening with... let me see. We were talking about it a little bit later, but as far as some of the advances in iray itself, can you switch back to my tablet for a minute? Okay, so before we were talking about actually what we call the integration platform, how we add iray to an application and all the benefits thereof. Now we're talking about iray itself. Okay, so iray is kind of a feature within this platform. And iray 2 is being integrated now. Bunk speed shot and bunk speed move are actually shipping with version 2 of iray. Is that correct?
That's correct.
Right. And will the new 3ds Max include 2 as well?
Not this year.
Not this year? Okay. And
No, actually, it will.
yeah, I thought so.
You're right. Sorry.
Thought so. And then the capabilities of iray 2 are starting to get exposed then by the tools. You want to explain the layered material model?
Sure. So in the past, iRay's 1.0 material model was a double-layered material composed of BSDFs, binary scattering distribution functions, which closely approximated what in 3ds Max was called the MIA material or the ARC and design material. So it was a very rich BSDF model with a lot of parameters and inputs, but it only had 2 layers. It was quite good at doing everything that Max and Mental Ray could do for photorealistic rendering. However, it was somewhat limited. So in iray 2.0, we implemented a complete new BSDF-based layered material model where you can have essentially any number of layers, and each layer has a collection of BSDFs, which are an expanded collection including subsurface scattering and paint flake simulation. Each of these layers can be controlled through textures and the blending of the layers and the refraction and IOR between, or the transmission between the layers can be controlled by either constants or textures as well, UV textures as well. And then all of this will work in the GPU and gives you a much richer set of materials. For example, you could build a car paint material with 3 layers, a top varnish coat, a paint flake layer with varying paint flake sizes, and then on the bottom a diffuse reflective layer. And that's only 3 layers. You can go much higher than that. You can also do skin simulations, milk, lucite, all sorts of things that we can even do back reflecting surfaces like velvet, which you couldn't do before. So we think this is probably one of the most competent and powerful layered material models in the industry, all based on BSDFs and EDFs for lights, emission density functions. And this is part of iray v2 core and will be starting to be revealed in applications like bunk speed and hopefully the other. I can't talk about other applications because we can't talk about them until they come out. But
right.
You can imagine other people are looking at implementing as well.
Now, this isn't just a complex material. You can actually layer different shader models on top of one another, right?
Right, with different BSDF models on top of each other, decal cutouts, all sorts of...
Right, but it's not just a decal on top of the car paint. Now you actually have vinyl on top of metal.
That's correct.
Yeah, that's hard to do.
Yeah, so this is a very, very powerful model.
Right. Okay. And that was kind of a lead-in to, also here, increased performance on some of the really tough lighting positions. I was wondering if you could load the attic scene.
Sure.
Okay. So sometimes features don't get exposed. They just work better. So this is a situation within 3ds Max. They didn't expose new functionality, but because the underlying iray rendering engine got better at its job of dealing with complex lighting, so did Max. So, call it a big bug fix, call it just a general improvement. In general, what took a long time to resolve before now goes much more quickly. So now if you could switch back to the demo machine. For any 3ds Max veteran, this is a really old scene. This used to take like overnight to render with volumetric lighting. And now it's shooting through and being resolved very quickly by iray 2 running in the new Max. Do you want to talk about why this is hard?
Yeah, this is hard because all of the light is indirect. It's coming in through the slats in the windows. And so basically everything that you're seeing except for the really bright bands on the floor are indirectly lit through a very large number of multiple bounces throughout the scene. So this is a very difficult lighting situation. And you can see that it's being handled quite quickly. Let me just rotate. I've got both GPUs running now, so it's going to be a little bit clunky on the here, but you can see it converge faster. And so this is again a situation where this kind of image a few years ago in a standard renderer like Middleware would have taken what, an hour or something?
It's taken a while.
Something like an hour to resolve. Yeah. And here you can see the result in real time. And again, in iray v2, the difficulty of this type of lighting is handled much better. So things converge faster, and you get better results faster. All this is transparent to the application.
Okay. Now back on me. Okay, so iray 2 is being integrated right now, or starting to be exposed within applications. iray 3 then will be coming out next year, and you do want to give a little.
Sure. So the next big step in iray 3 is not so much visible to the application because the new layered material model gives you an extremely powerful material. We wanted to get that out of the way. Now what we need to do is we need to improve the core, and so the next big step for iray is to use bidirectional path tracing techniques inside the core to speed up really difficult lighting situations, like difficult caustics, or just in general, if you have light coming in through a small opening, illuminating a room or something like that. These are cases which iray currently handles, but not as fast and not as well as it should. So the next big step is a huge improvement to the algorithms and in the core. This is what we're focusing on for iray 3, which should be coming out next year. And in addition to that, we're also we're increasing our work on interactivity, and also memory management in the GPU. So right now, iray doesn't allow instances. I mean, instances are allowed, but they have to be replicated, which means it can eat up memory, and also it's a little bit slow to move things around in the scene. So we're really putting a lot of focus in the next version on more interactivity, being able to change the scene much more quickly, and being able to have large scenes with instances, for example, a field of grass in front of your house or lots of replicated objects, and have it take up less GPU memory so that you can fit larger scenes inside the GPU, which is important for performance. So a lot of the changes in V3 are under the hood, but they will make it just run probably, in a lot of cases, 2 to 3 times better for difficult lighting, and noise reduction would be much faster.
Okay, great. Okay, now switching from the commercial platforms to basically an underlying framework to help you, we'll talk about the OptiX ray tracing engine. Now, the images I'm going to be showing here are a little less obvious, not quite as famous. I mean, this one is actually coming from Lego that uses OptiX for their Lego Universe game, calculating a critical part of that gameplay. This was actually from a demo we did last year. This is from Lightworks. This is showing how OptiX is being used for implicit surfaces. It does not need to have triangles. You can actually just render anything that's an algorithm. And then one of our more famous demos that we did with OptiX, sitting on top of the Scenics framework, was also Design Garage. So this is some of the places you might have seen OptiX. In truth, OptiX is having a lot of adoption, but it's more private. So it's under the hood. You see it's being used at many companies, many brand name companies, but whose results we really can't show because they're not commercial. So what is OptiX? If you're brand new to what it is, OptiX, it's comparable in a way to OpenGL in the sense that OpenGL provides you a driver that accesses hardware. You, as a software developer who's writing an OpenGL renderer, concentrate on your shaders and your fragment programs, things like that. And you don't have to worry about all of the code that's underneath that actually accesses the hardware and just exposes it to you as APIs. You've just become accustomed to it. It's just there. Well, none of that is there for ray tracing. For ray tracing, you get to do all that on your own. You get to figure out how to do an acceleration structure, how to do threading, how to balance your loads, how to access data, how to make all of that work on the GPU. So OptiX's job is actually to take away a lot of that drudgery. It's to do the heavy lifting for you so you can concentrate on the fun stuff. You concentrate on the rendering portion, what makes your renderer yours, what gives you your look, your approach, your technique. Any technique is possible. We simply make it fast. So again, it's making it so it's very easy for you to use. It's extremely general. It doesn't assume anything. You can have, if you have a special way of generating your triangles or want to work with procedural surfaces, that can all be done implicitly. And in general, it also has been shown to speed the overall development speed of creating a renderer, not just making it faster. We've had numerous people actually, give up on a renderer they've been working on for numerous months and get farther within a few weeks based on OptiX than they were hand coding. And of course, the result was much, much faster. So places that you can see this going on right now, in our booth this year, you'll be seeing Adobe. Adobe is going to be showing something that they've been doing in the research group. They have a compositing framework all set up that is showing the use of ray tracing in a compositing environment for motion graphics. It's really interesting. Stop by. You can see OptiX within more of a commercial environment right there. We're also beginning to use it internally. We talked about OptiX being used within Middleware, and we're looking at using it in many other areas within our commercial offerings in-house as well. And then one of the bigger news is coming out at this show is that the next release of OptiX will be supporting what we call out-of-core memory. This means that scenes will no longer have to fit within the GPU's frame buffer size. You'll now be able to exceed it and work within basically your system's RAM size. So, talking more about that. So version 2.5, we've been concentrating on this for a while. This is a general approach. It will work for any type of rendering, not just a specific type or technique. It'll work for things that aren't even rendering if you have a ray tracing approach. So you're now paging to system RAM, and your scene size is limited to your RAM limit, which is very similar to what you have on the CPU. This isn't free, of course. As soon as you exceed GPU RAM, you do take a speed hit. But that speed hit is then constant until you run out of system RAM. So in general, we're about 12, 14 times faster than a quad core. The speed hit will knock you down to maybe 5 or 6 times faster than a quad core. So it's a noticeable hit, but it's still many times faster than running on the CPU alone. We'll be talking about this much more in depth later this afternoon at the 4:30 presentation. Then version 3, coming out the first half of next year, this one's going to be optimized for our next GPU architecture. Right now, we're running on Fermi. Kepler will be coming out next year, and as OptiX is part of that design and feedback loop we talked about before, it'll be coming out on the heels of that new architecture, already dialed in for it. So your application that's running on OptiX can take immediate benefit on a new architecture. This is really important because sometimes the approach you use to program on the GPU will change radically between architectures. Not because it has to, but because you want to. Because the way you did it last time may not be the fastest way to do it the next time. And we figure this out for you so you don't have to. Also a part of this is, believe it or not, we'll be having a CPU fallback for OptiX. Currently, OptiX requires an NVIDIA GPU, any type, to be operating. Coming with version 3, the first half of next year, we'll be having a CPU fallback. That will be a credible speed fallback onto x86 processors. We're doing this because we're getting more widely adopted in commercial applications, and as you all know, the more widely you're promoted, the more you have to run on anything. So we'll be supporting x86, and we need this for ourselves. As we're starting to use OptiX within our own commercial development, we need our own features to be falling back to the CPU. Now, What's next? Okay, we talked a little bit about the technologies, where they're going. This is a little bit further out. This is where we see a lot of this stuff converging and what we're really working on. Michael talked a lot about iray 3 as being a feature set. That would be here. But what we really see is iray having a continuum of rendering companions or modes that you can choose between according to what type of interactivity you want. The idea here is that for a full resolved image, iray takes a few minutes. Now, as you saw when Michael was manipulating it, you can get about 10 frames a second while it's being degraded. But that's still degraded. What you want is something that is noiseless, but still giving you the interactivity. So we're going to be creating a different mode that will sit side by side with iray to give you that type of interactivity while still being fully ray traced. At the same time, we'll be creating an ultra-fast raster-based renderer so that you can scale up to any size viewport and maintain stereo quality speeds. So the trade-offs on each of these is different. With iray, it's physically correct, but it's noisy. With ray tracing, it's not noisy, but it's no longer physically correct. And with raster rendering, you can go to any size resolution, power walls, caves, whatever you like, but it's very, very approximate. What we're going to be doing, our goal here, this is our vision, is to have these things cooperate with one another in a way where they can share data, memory, and materials. That's the key. Now, we're working on this. We can't show it yet, but we wanted to give you an idea where we're going because we think this is very exciting and it's what the industry really needs as far as pulling all of these solutions together. Basically, a continual quality speed dial that you can adjust as part of your application and use it as you need to. So if you're to take a look at not just performance and realism as we graphed before, but also size, both model size and screen size, you've kind of got three axes of what a renderer is good at. And with these different flavors, we believe you'll have what you need to dial in the user experience for any given time. For example, you could be manipulating the viewport in one mode, on mouse up, change to another mode, in production rendering, go to another mode. It's all up to you as a developer, how you integrate it and how you expose it. So that's what we're going to be looking at, and hopefully come next SIGGRAPH, you'll be able to see this in action, and we'll be able to talk seriously to you about it. Okay, well, we're running out of time, right on time actually. And so if you want to learn more about GPU ray tracing and what's really happening with OptiX 2.5 and out of core, what's happening with Middleware and its GPU usage, and some of the new iray capabilities, and how that's working with the GPU, we have a full session on just GPU ray tracing at 4:30. So come on back. We'll get more detailed, much more technical at that session. If you want to try OptiX itself, you can. It's downloadable from free from the developer zone up on NVIDIA.com. And then all the forum support is up there as well. You'll see a lot of people talking about OptiX and exchanging tips and tricks on what is happening. And then for Middleware or iray, you can contact either Ludwig, who's sitting in the back over there, or myself. Ludwig is based in Europe. I'm based in the United States, so we've got most of the time zones covered.